What we have here is geotrig lesson 41. Today it is reciprocal trig functions. The reciprocal trig functions are based off of the original trig functions, which I call the big three. And the big three are the sine, the cosine, the tangent. We remember those by some old hippie caught another hippie tripping on acid, or SOHCAHTOA. You guys should have no questions on what SOHCAHTOA is, what it stands for, and how to use it. That means if I ask you what the sine of 30 degrees is, you guys automatically should know what to do. Reference triangles, write down SOHCAHTOA, it's opposite over hypotenuse, which ends up being 1/2. If you guys can do that, then you guys will have no problem with what I'm going to call the little three. And the little three are the reciprocal trig functions. We have cosecant. Cosecant of theta is 1 over sine theta. We also have secant. Secant is 1 over cosine theta, and tangent theta is 1 over, whoops, that's not tangent, should be cotangent, sorry. Cotangent theta, and cotangent theta is 1 over tangent theta. They say these are the reciprocal functions because they're the reciprocals of the big three. Okay? And then these guys work just like all the rest of the ones you've done, where all you're doing to evaluate with these functions is to switch them to the more familiar version of the big three, and then once you're in the version of big three, you can then evaluate using SOHCAHTOA, using the rules of order of operations, and all the rules that you know how to simplify by, then you're going to be fine. COT, yes. Cotangent theta. So we got cosecant, secant, and cotangent of theta. Before we move on to the next slide and start to evaluate these things, I also want to highlight the fact that I can also say that sine of theta is the same as 1 over cosecant theta. Cosine theta is 1 over secant theta. Tangent theta is 1 over cotangent theta. These are interchangeable. You can switch between the two as you would like. And again, I'm always, or not always, but most of the time, I am going to switch any of the reciprocal functions to the big three because it makes my life a lot easier. Okay? So, let's go on to actually using some of these. Now, I have a triangle here with just a whole bunch of variables. I got X, Y, Z, and A. And I want you to state all 6 trig functions of A. So the sine of A, the cosine of A, the tangent of A, the cosecant of A, secant of A, and cotangent of A. So let's start listing those. I want to know sine of A, cosine A, tangent A. All of these will equal some kind of ratio, right, of sides to side. We then can talk about the cosecant of A, the secant of A, and we can talk about the cotangent of A. Maybe to help us, because we do have the triangle, or using sine, cosine, tangent, on the top of your paper, you very well might want to write SOHCAHTOA, right? Because that's going to help us identify sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So sine, if A is here, what's the opposite? Over Z, yes. So it's y over z, opposite over hypotenuse. Cosine. What's cosine? Adjacent over hypotenuse, which is x over z. Tangent ends up being
Y over
x. Not that big of a deal. Everyone should be able to handle that without any fanfare. It's all good to go. Now we've got to go to cosecant. Isn't cosecant 1 over sine A? Okay, so wait. So let's write that once. That's 1 over sine of A. Do you know what sine of A is?
Yeah.
Isn't that just 1 over y over z? Wait a minute. I'm dividing by a fraction. And when you divide by a fraction, you do what? You get the reciprocal. Or you multiply by the reciprocal, which ends up being z over y. Oh. Is there a connection here?
Yes.
We just flipped it. What do you think the secant of A is going to be? It's z over x, yes. Cotangent A
Is x over y.
is x over y. So it's really easy, guys, if I'm able to find the sine, cosine, or tangent of something, to take the reciprocal, and now I have the secant, the cosecant, and the cotangent. It's awesome. It's quick. It's easy. So now we have to start to evaluate. Notice that I took away all the sines and cosines in our problems. You have a secant of 330 degrees plus the cotangent of 480 degrees. Now guys, we've already talked about radians. So, hey look, on the second problem, it's in radians only. It doesn't matter if I mix them up, some being degrees, some being radians. It's all done the same way. What you guys can't forget is that sometimes you go to angles that are coterminal. We talk about reference angles. And now we have to talk about reciprocal functions. So it's all in there. It all has to be taken into consideration. So, like 330 degrees. I don't want to use 330 degrees. I want to use something else. What would I rather use than 330 degrees? What's a reference angle to 330?
Something
No. I'm not looking for a value. I'm looking for reference angle. I want to say secant of 330 is the same thing as secant of what? It's 30, because here's 330, right? What's the leftovers to get me to the x-axis?
30.
It's 30 degrees. So therefore, secant of 330 will have the same value as secant of 30. I can do the same thing with 480, right? Where's 480? 480, that's 180, 360. How much more do I have to go?
180.
No.
No, whoa.
120. So I got to stop over here, right? Now, here's a question. That means that the cotangent of 480 is the same thing as the cotangent of 120. Are you guys okay with that? Okay. There's more to that. What's the leftovers to get to the x-axis on that one? It's 60. So therefore, there's something with the cotangent of 60. The question, though, that you have to kind of ask yourself is, if I change this to 60, do I have to put a negative there someplace? Or do I not need a negative? I should have asked you this on the secant of 30 as well. Secant is the reciprocal of what? Back in your notes. What's that? Secant is the reciprocal of cosine. Cosine in the fourth quadrant is positive. So therefore, if 30 is positive, it doesn't matter. They're going to both be positive. I don't need a negative. But take a look at tangent, right? Cotangent is the reciprocal of cotangent. In the second quadrant, is tangent positive or negative? You guys remember how to figure that out? All students take calculus? You guys remember that? So all students take calculus. That tells us which quadrant each trig function is positive. And in the second quadrant, it's an S. That actually stands for sine. So its tangent in the second quadrant is negative. But if I use cotangent of 60, 60 references the first quadrant because all reference angles reference the first quadrant. Cotangent will be positive, or tangent will be positive. So therefore, I need to have a negative in front to make it all good. Bless you. At this point, I have now got all my reference angles taken care of. I now want to switch everything to the big three. And here's the thing, you could have switched to the big three first and then found all your reference angles. It would not have mattered. So, secant of 30 is the same thing as 1 over cosine 30. Minus cotangent is 1 over tangent of 60. And now you just have to ask yourself, what's the cosine of 30? You have a unit circle. You have reference triangles. You know SOHCAHTOA. What is the cosine of 30? Square root of 3 over 2. So, continuing on, what's tangent of 60? It's just the square root of 3 over 1, right? Here's the problem. I got complex fractions. I got 2 of them. I'm taking a number and dividing by a fraction. And when you divide by a fraction, you need to flip and multiply. So that means that 1 over the square root of 3 over 2 becomes 2 over square root of 3 minus 1 over square root of 3. Can you guys see that or not? Now here's the thing. Some people are looking at this right now and saying, whoa, 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 I don't like square roots on the bottom. So we should fix those, right? But, yeah, hopefully some people are saying, wait a minute, they both have a square root of 3 in the bottom, which means they have a common denominator. I'll take care of that first. So you end up seeing that it just becomes 1 over the square root of 3. And then if I fix that, I multiply top and bottom by square root of 3 over 3. Done. That's an exact answer. If you put it on your calculator, you'll end up with some decimal, probably 0.5 something. That's not what I want. I want that. Square root of 3 over 3. You got to take everything one step at a time. We're going to do the exact same thing, but this time with radians. I want you guys to switch it first this time. Switch it from the little 3 to the big 3 first, and then find coterminal angles and reference angles. Staying in radians. Guys, what we have here, like I asked you to, switch it first. That means the 2/3, which is up front, is times 1 over Cosecant is 1 over sine of negative 3 pi over 4 minus 1 over,
11 pi.
no,
Oh, a negative 11.
it's
It's
cosine 11 pi over 4. All I did this time was change it to the big 3. And at this point, now I am going to find coterminal angles for negative 3 pi over 4 and 11 pi over 4. Make them more manageable as an angle. The 2/3 is still going to camp out front. I'm not changing that. I still get sine and I still get cosines, but now I'm going to change the value inside of the angle to its coterminal angles. If you need to, draw yourself a diagram. So if I go backwards 3/4 of pi, 1, 2, 3. There I am. I'm in the third quadrant. By chance, in the third quadrant, sine should be what? Negative. So when I find the leftovers, which is this part right there, happens to be how much more? Every time you took a step, you went how far? A pi over 4. So how many more steps do you need to take? 1. So it's 1 pi over 4 more. So that means that this is still 2/3 of 1 over sine of pi over 4. But because it's in the third quadrant, sine has to be negative. Minus 1 over. Now we're talking about going 11 pi over 4. Taking 11 steps of pi over 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Where do I end up in? Second quadrant.
So it's negative.
Cosine would have to be negative as there as well, right? So it's a negative of cosine. What made the leftovers get to the x-axis there? Pi over 4. You can leave it as 3 pi over 4, but then you would not put a negative up front. Because then, if you went just 3 pi over 4, it would take you there. That's not a reference. So if I'm not referencing, then you're fine with leaving negatives as they are. Because remember, reference angles always reference the first quadrant, and anything in the first quadrant is always positive. We don't have to deal with it. But this is probably the easiest way to go. Hey, wait a minute. What is the sine of pi over 4? It is square root of 2 over 2. Minus, hey, what's the cosine of pi over 4? So, hey, it's still the same, square root of 2 over 2. A negative minus a negative will be, so is everybody okay with me just changing the negatives at the end to both positives? That'll save us a little bit of time, maybe a little bit of grief.
Is that
So now we got to keep going. I'm dividing by a fraction of square root of 2 over 2's. So I need to flip both of those, right? So I get 2/3 times a negative 2 over square root of 2 plus 2 over square root of 2. Are you guys okay with that? Now, we have to put those together. The problem is that you're multiplying the first group by 2/3, which changes the denominator of that first group. It's not the same as the second group. Now, we have options. I could fix the denominators right now, because they both have a square root of 2 in them. Or I can match them up together to put them together and then fix it. Doesn't matter. Which one would you like to do?
Match 'em up.
Let's match them up first. Okay. So if I match them up, I think everybody should agree that it'd be a 3 and a 3 on the second fraction. Which means that I'd have to have a negative 4 over 3 square root 2 plus 6 over 3 square root 2. Can you guys see that? And when I put those together, I end up with 2 over 3 square root 2. And multiply the top and bottom by square root of 2. I'm going to run out of room here, but square root of 2, square root of 2. And so, I end up with 2 square root of 2 over 3 times 2. Oh, wait, what happens with the 2's?
Oh, they cancel.
The 2's cancel. I get square root of 2 over 3. See, the thing is about these is that I don't think the switching from the little 3 to the big 3, the idea of taking a trig function and switching it out with its trig value or its ratio is a problem. It is all the rest of this stuff, which we call algebra, is going to be the problem. Because people forget that you have to have a common denominator. They forget that when you divide by a fraction, you flip and multiply. You don't like complex fractions. You don't like radicals in the denominator. All things that need to be worked out, because I do not, and I repeat, do not want a decimal answer. Now, where will your calculator help you? The answer you get from putting this on your calculator should match when you divide those two on your calculator. Then you can say, yep, I did things right. But other than that, no calculator was even used for this process. And they shouldn't be used. So in that case, do the next one. Secant of 10 pi over 3 plus cosecant of a negative 7 pi over 2. So, to start this problem, again, you have a choice. Do I switch to the big 3 first, or find coterminal angles and reference angles? Which one did you guys find easier to do? Switch first. Okay, so let's switch these first. So, secant is 1 over cosine of 10 pi over 3 plus cosecant is 1 over sine of negative 7 pi over 2. So our first move, now we are in the big 3. So technically, you just go to your reference triangles, reference angles, unit circles, SOHCAHTOA, we're good to go. And then it's just algebra from there. So 10 pi over 3. Now, can you guys realize that I'm going around the circle more than once? Because 2 pi would be considered once around. 10 divided by 3 is 3 something, right? So it's actually 3 some pi. So you know you're going around more than once. So what we can do is you could technically simplify that and work things out. Or again, just draw yourself a nice little diagram. Going by thirds. That's a third, that's a third, that's a third. And a third, and a third, and a third. And now you just count 10 of those in a positive direction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We end up in the third quadrant. Everybody see how I just counted? I took 10 steps of pi over 3.
Yeah, but did you skip the...
Did I skip one?
Yeah, you skipped like 3.
I thought you skipped 2. I thought it was supposed to be the one up top there.
No, this
Yeah,
would
I
be
No, that
90.
one. That one.
So this is 1,
Okay.
2, 3, 4, 5, 6, 7, 8, 9, 10.
Okay, so the y-axis doesn't
The
count?
y-axis is not counted in this
okay.
because it's not an angle of pi over 3 or 60.
Okay.
I'm really going by 60s, right? Pi over 3 is 60.
Okay.
So I'm only going by 60, 120, 180, 240, 300, 360.
Okay, that makes more sense.
Now, that means that I've actually, from the x-axis, took one extra step further, didn't I? So could I then say that this is the same thing as cosine of pi over 3? That's a reference angle. Now, we also have to figure out the fact that this is cosine. And I'm referencing the first quadrant. I need to take care of any negatives. In the third quadrant, cosine has to be what? Or is what? Negative. So therefore, I need to add that negative in there to correct it. I need to adjust for the fact that it better be negative. But when I reference the first quadrant, it's never negative. I do the same thing for negative 7 pi over 2. Now, pi's over 2 are going by what, if I switch it to degrees?
30.
Not 30. Pi over 2. Pi is 180.
Oh.
Divide by 2? 90s. So, hey, look, I already got the 90s right there.
So it's 4.
So I go backwards, right? So if I start here, I go 1, 2, 3, 4, 5, 6, 7. So I actually am at this one, which is just pi over 2. Now here's an interesting thought. Do I need to have a negative or a positive in front?
Not with this.
Sign is positive on the top side, right? So this should be fine with a positive. So here we go. Ooh, what is the cosine of pi over 3? Go to your unit circle. We did radians. What's pi over 3? Go to cosine. X value. Don't everybody look at your unit circles. Pi over 3. It's 1 over 2. That's pretty nice. And then, plus, what is the sine of pi over 2? It's 1. Ooh, that's even easier yet, because 1 divided by 1 is 1. Hey, what's 1 divided by a negative 1/2? It's negative 2 plus 1, which is negative 1. You can't get any easier than that. Okay, guys, last one. Cotangent of 17 pi over 6 minus the square root of 6 times the cosecant of negative 9 pi over 4. Not a lot of time left, so we will jump right into it. I don't like cotangent, so it's 1 over tangent of 7 pi over 6 minus the square root of 6 times 1 over cosecant is 1 over
6.
sine of 9 pi over 4. You guys notice that I have not changed anything with those fractions or the angles themselves?
Yep.
I'm only changing the function itself. Now, 17 pi over 6. If I took 17 divided by 6, I get 3 and 1/6. No, I don't. I don't get 3. I get 2 and 5/6, right?
Yes.
So, technically, guys, I'm going a pi, I'm going 2 pi, and 5/6 of a pi. And if you don't believe me, you can put all 6 pi's into each pot, each 1/6 of a pi on top and bottom, and count up 17. You will end up in the second quadrant. Tangent in the second quadrant is negative. So this becomes 1 over negative of tangent of a pi over 6. because it's a one step away from the x-axis. Minus the square root of 6 times 1 over. Now here's a cool thing. This is a pi over 4. All sines of pi's over 4 end up being a pi over 4. Just got to remember if it's positive or negative. Your homework is a worksheet.